All right, let's start. So thank you for coming to my little talk here. I'm pretty sure there's a lot of other interesting topics, so thank you for coming. We're going to talk about something really fun, hacking multi-factor authentication, which is kind of funny because a lot of security experts, they say MFA is the solution to solve all our authentication problems. So I guess I'm going to prove that that's maybe not completely correct, not by itself at the very least. But let's start a little bit who I am. My name is Niclas Kjellin, and I've been working within this field for quite many years now, so I stopped counting them because I just realized I'm getting older. So hopefully I learned something along the way. I have a developer background. I've been a security engineer, security architect. I've been a CTO for a couple of security-related companies. I've been a CEO for a cybersecurity consultancy firm. And I do some research as well within this field, particularly looking at authentication, passwords, and cryptography. So that's really my home game. But we're going to talk about multi-factor. So I'm just going to start to sort of make sure everyone knows what this is and what we're looking at. I'm quite sure you know what MFA is, but just in case. So we talk about different factors. So there is something you know, which is your password, your PIN, or something like that. And we all have this. We all use it daily and so on. And how wrong can it go with your pet's name? So we figured that one out. And then we have something that you have. And nowadays, that's usually your mobile phone. So it's a device that we're using as a second factor. That could be an SMS code being sent to your phone, or that could be an authenticator app running on it. And finally, the third factor, or of the classic ones, is something you are. That's biometrics. That's our fingerprints, palm, retina, face, and so on. And there's a misunderstanding around biometrics because it's not an exact science. It's just an approximation of the likelihood that you are the same person as been registered before. So you don't tend to use that factor by itself, or you shouldn't. Most of you use it to unlock your phone, but there is a fallback to your PIN code anyway. So in a way, it's not actually the first factor used. And your face is always good because it's not like we filled the entire social media networks with lots of selfies of ourselves anyway. So a couple of claims around MFA. So about 99% of automated cyber attacks are stopped by MFA. I think it was Microsoft that said that. So that's a pretty good track record. 96% of phishing attempts are stopped by MFA. Those are, again, very, very good, very bold claims. And 76% of all targeted attacks, that's where you go for one individual and just try to hack that person, also stopped by MFA. So the problem with all these statistics is that they are assuming that we didn't actually target the multi-factor method used. So if we were, most likely these numbers look differently. Let's talk about the feelings we get when we come to MFA. So, you know, all the emotions. You're going to have to do an MFA authentication. What kind of emotions do you get when you end up with that? What emotion, feeling do you get from MFA? Secure. Yeah, that's good. Yeah, that's a good. Most people don't say that. Any idea? Annoyed. Yeah, it's pretty much annoying. 33% of people are saying that. It's too complicated, it's too slow, and so on. There is no good feeling about MFA. It's just something that stops us from getting our work done. So it's actually a fact that about 80% of people abandon their accounts when they're faced to having set up multi-factor. So that's like if you have an account somewhere and that company decides, okay, we're going to force everyone to use MFA, and you can't be bothered and just leave it. Or if you're signing up and the final step is, now you have to set up an MFA method, and you go, I can't be bothered to do that today, I'll do it some other day. And that never happens. So revenue-wise, it's not a good idea to use multi-factor. almost half of employees have tried to bypass MFA at some point. So if your room is split here by the stairs, so all that side has been bypassing MFA. You shouldn't do that. And maybe you didn't know you did. I was talking to a client of mine just a few weeks ago, and they were running this tool that took a very long time. So the session kind of timed out, and that's caused problems. So they wanted to extend that session, and there was multi-factor authentication baked into that. And they said, well, can we extend that? We were thinking of doing it like forever. I was going, maybe that's not the best idea. So don't do that. 10% of Microsoft and Google accounts are protected by MFA, so a very small minority. That's all accounts, including private accounts. If we were just looking at employee accounts, it would be about 30%. So still not very many. So again, if we just move this split a little bit further down here, so you get 1/3, you guys are using MFA, you're not. So you guys here, this talk is not for you. Please leave. No, sorry, stay. You can just stay, listen, and then laugh at that lot. Sorry. So attacking MFA, what can we do? Well, we could do brute force. That's a valid method. It's not the best one, not the most clever one, but when you do brute force, you do it towards something else. It could be the recovery codes. So hopefully there's a weakness in that, so you try to force your way in through another channel. We can do SIM swapping. That's when we divert SMSs from one phone to another. We have to convince the telephone operator company to switch a little bit there so we can get it instead of our target. We have MFA fatigue attacks. This is what you get bombarded with any number of requests to approve a MFA. And hopefully you tire at some point and just accept it. We have something called session hijacking. And here we're really talking about information stealers or infra stealers. That's a malware that gets installed on your machine, and you just try to figure out which session tokens are nice and send them off somewhere for someone else to use. And then we have man in the middle, which is more technically called reverse proxy in this case. We're going to dive a little bit deeper into that one soon. But this number is interesting. Almost 70% of all breaches have some sort of non-malicious human element in it. So it's a friendly person helping out. And they do it maybe because they don't know, they don't understand better, or you're just tricked into doing it. And this is really what you're using. If you want to bypass multi-factor authentication, this is the way to go. Attack the human person. A little bit more technical skills involved as well, but it's a very central piece. SIM swapping. So SMS OTP, one-time password, is still the most common method to that's used for MFA. Lots of banks, cryptocurrencies, sites, and so on are using that. It's very highly targeted, I would say, because it rose about 400% of attacks over the last year. There's a lot of money to be made in this. I think it was 2023 last year. There was a guy in California that got his phone SIM swapped or his number SIM swapped. And they managed to pull out $24 million through cryptocurrency. So a lot of organized crime is on the SMS side. But it's not the only attack, but we come to that. So you've probably seen this screen depending on what kind of accounts you have. So this is a two-step verification screen from Google account, Google Workspace. And you're going through the username and the password, and now you end up at this screen, and Google's going to send you an SMS, and you're just going to enter that to log in. And we can of course hack that. We're unfortunately not going to do that live here now today. It'd be fun though. But I do have a little video to just give you a little taste of how that looks. And in this video, there's this woman called Jessica Clark, who's really good at this. It's about 30 seconds long, and during that period, she will get access to the other guy in the videos, his email account. And the full video is 2 minutes or so, and if you watch the whole thing, she would actually end up having access to his phone number as well. But this is just to show you a little bit how this works. So hopefully the sound is gonna work really nicely as well.
Hi, I'm so sorry. Can you hear me okay? My baby, I'm sorry. my husband's like, we're about to apply for a loan and we just had a baby and he's like, get this done by today. So I'm so sorry. I can't call you back. I'm trying to log into our account for uses information and I can't remember what email address we used to log the account. The baby's crying and can you help me? Awesome.
In just 30
At
seconds,
gmail.com?
Jessica gets access to my personal email address.
So this is really how easy it is if you have the stomach for it, because you're going to have to trick someone else to do something they're not supposed to do. And you usually call some sort of support. And why do you do that? That's because they're there to help you. As a matter of fact, in their little job description, in bold capital letters, very fat font, larger than everything else, underlined a couple of times, circled around a couple of times, it says, your number one task is to help our customers, and never ever should you create another problem for them. So that's what they're working with. So that's why it's so easy to hack people and get, for example, SIM swapping in place. So we're going back to our little two-step verification screen. And let's assume we just did this now. So basically now we're just going to have to wait for this SMS to show up on our phone. And you know how it is. Everyone thinks MFA is too slow. So we just should come on any second now. Should be here, waiting for it. It's slow. Oh, there it is. So the 6 digits from Google, we just type those in and we're logged in this case as Elliot Alderson. This is his Google Workspace account. So this gets access to everything that company has, Google Docs and so on. And potentially a lot of other accounts as well, which is quite nice. You just say, thank you, SSO. So that gives access to other systems that may be linked to this account. Moving quickly forward to MFA fatigue attack. So now you're just going to have to imagine it's early in the morning. You're still sleeping. And then all of a sudden your phone starts buzzing and beeping and vibrating and everything. And it goes a little bit like this. You end up getting all these notifications coming in very rapidly all the time. And you're just bringing up your phone to see what's this about. You think, oh, this is wrong. This should not be happening. You're still not fully awake. So you just want this to go away and go back to sleep. You may see this screen. Do you get a couple of few options there? You don't know which one is correct. But maybe you're tired enough to start pressing some of them. And after 3-4 tries, you probably get the right one. And then the problem goes away. You can go back to sleep and it's all happy again. Also, you let a hacker into your corporate system, but that's beside the point because you get to sleep. If that doesn't work, if the employee or whoever it is you're targeting doesn't actually answer and accept this, you can do this and then try a little variation of it. In 2022, when Uber was hacked, the hacker who hacked that, he wrote a couple of things afterwards how he did that. So this is actually a quote from him. He was spamming this employee with this authentication notifications for about an hour or so. And then he contacted this person through WhatsApp, claiming to be Uber IT, saying, we have a problem with our systems. And it just keeps on sending MFA notifications. If you just accept it, it will solve the problem. So this employee did that, and of course the problem was solved. And Uber's network was also compromised, but at least this employee solved his problem. Sometimes it looks like this. I'm just using Microsoft Authenticator as an example here. You have to type something in here. You don't know what the right number is because it's on the screen somewhere else. You can't even guess. Sure, someone can contact you, give the number, but let's assume they don't. So this is where we need to bring out the little larger guns, the big tools to do this, which is known as man in the middle. And there's a lot more technical stuff to this. You may have to install something, compile it, run it, configure it, whatnot. But of course, we live in the modern age. So we have something called cloud and something called dark web. When we combine those two things, we get everything as a service. It's very handy. So this is an actual screenshot from a site, a service on the dark web that is called Evil Proxy. And you can buy man-in-the-middle attacks here. You don't need to understand anything. And if you want to attack Dropbox, for example, and you want to do that for 10 days, it's cost you $150. If you want to attack Microsoft 365, do it for a month, it costs you $400. So you're basically trading dollars for simplicity. And it's just click buttons and fill in forms and so on, and then you can sit back and relax and just see who falls into your trap. Very convenient. But we're not going to do that. We're going to do it a slightly more technical way here today. So we're going to use an off-the-shelf tool, which I prepared. But firstly, we need to have a target. So who's going to be? No, I have that prepared as well. So imagine there is a company called Rock Paper Security. And they are working on some cool stuff that you're really interested in getting your hands on. And I think in this room, we can all agree that the most valuable asset a company has is their source code. So that's what we're going after. And we think they have it on GitHub. Because we've seen that they have public repositories, because we also need to know who we're going to target. So we were browsing around in their public repositories where they've been so kind to release free, nice tools for everyone to the entire world. And we stumbled upon this file called build.gradle. And we were looking into it, and we just saw some information in here where there's a name and an email address. You know, most likely this person has access to the rest of the repositories of this company. So we're going to grab that with us, and then we're going to see what we can do with that. So the tactics here is a little bit like this. So the user is going to log into GitHub, but we want to put something in between. And we want the user to go through our proxy service when going to GitHub instead. Now that doesn't happen automatically, so we're going to have to figure out a way to get the user to do that. And the way we're going to do that is to give him a present that he cannot refuse. Something really nice, or maybe not so nice, that he has to do something about it. So we pull out our little, brains to think up something. So we may write this text. Basically, it comes from GitHub, and it says that within 24 hours, his account is going to be closed down, and all the repositories is going to be deleted permanently. And it kind of looks like he has actually requested this. So now is the final notice. This is going to happen soon. And God knows how long this is going to be in his inbox before he actually reads it. So there's a sense of urgency in here. You need to do something. But we're going to give him one more thing. We're going to give him a way out, a way to correct this, make it all good and shiny and happy again. So we put in this big red button saying cancel account removal. Very tempted to press that button. So now we're going to do that for real. So let's jump over to it's visible there, pretty good size as well. So I'm having just an SSH connection to a virtual machine here, where I'm going to start up a little reverse proxy. And the tool that I'll be using is called Evil Jinx. There are a couple of other ones. This is probably the most mature and well-developed one. So just start that there, and now it's up and running, as easy as that. And you can see it kind of lists a few fishlets. Those are like small configuration files that you can use. It says example, that's always there, and GitHub I wrote. And GitHub is a specific configuration to target GitHub. Just tells Evil Jinx how to handle the information that goes back and forth and what's interesting and what's not. I do need something called a lure. So I have one lure here for this fishlets. What it is really is it's just a URL that points to this fishlets 0. So here's the URL. So it says github.accountrecovery.com. And if I copy that, which is slightly difficult from this position, like so. And then I take that with me, and I have some HTML prepared here. So I'll just paste that in, like so. And I copy that HTML. Then I take a very trusty mail client, a very old one. It's been around forever, called Thunderbird. You can do this with any browser, any mail client. It's just that Thunderbird has lots of cool stuff in it, which modern mail clients doesn't. So here I'm just going to send a message. The new message is going to come from github@accountrecovery.io. And we'll take that address that we found on GitHub, the repository, and then we're going to do the nifty thing, which I can't actually see the menus on my screen. So insert HTML. And I'll just paste that in there and go insert. Very nice email all of a sudden. Even added a few buttons down here that's going to make it even nicer. Looks very legit. And I need a little subject line, so we're just going to copy. We're just going to copy this line here. No, not like that. Come on. This is the most difficult part for doing phishing. Damn. I'm going to type it soon. That's going to go quicker. So I'll just type it. But the thing is, I've done some research. GitHub always starts with square brackets GitHub in their emails. So I'm just going to do that, because that's going to look even more real. Final account removal notice, like so. And send. Hopefully we have an internet connection here now. Looks like it. So that's sent. Okay? I don't know to whom. I just picked an email address on GitHub. No, of course it's mine. But so let's assume we are Elliot here. So here's his Outlook. So he got this message now. He says, it says 14:18, but it's running an hour behind. But it's just arrived. And you can see, if I click here, you can see it's Elliot Alderson, his Microsoft account. So if he click on that, here's the email he got. Looks really nice. It comes from GitHub as well. That's great. You know, and he's worried at this point because he doesn't care about looking carefully at where this came from, because he read the text. So all that brain is shut down now. He's just worried he's going to lose everything. So we're going to hope he's actually clicking on that link. So I'm just going to bring up so we can see both here at the same time. So there's another visitor that came in here. Well, don't know who that was, but you know, that's collateral damage. So he clicks this link, it goes off, and as you can see in the terminal, it does say a new visitor has arrived on the second one there. And he's gone to the GitHub login page on his side in Chrome. So he's going to have to log in here. So he needs a username. So let's grab a username here. Like so. And we need a password as well. So now everyone is copying my passwords. Don't worry, I'll change them later. Maybe. We'll see. So he signs in, and you can see the green text in the terminal. It just picked up the username and password. So this terminal here, it's running a virtual machine which is about 40 kilometers away from here. So it could be anywhere. And all his traffic goes through this machine. And so now we know how to log in, except, of course, the two-factor that came up. So he's going to have to solve that one. So he brings up, you know, his little authenticator app and have to type in the code, which in this case is 436894. So he's logged in. He's not going to be bothered with passkey at this moment. Should, but yeah. So now he's logged in. It looks pretty okay from his perspective. if we jump over to this terminal here now, you can see on the last line it says all authorization tokens intercepted. That means we're good. We got what we wanted. So if I now type here sessions, there is, on the line 23, there is a session captured. There's the username and password, and it says tokens, and it says captured. So we have everything we want. So I go sessions and 23. It gives me a long string here. That's what captured. So I'm actually going to try to copy this, but I realize this is difficult because this screen doesn't give me the whole screen, not the same that you're seeing. So let me see. Again, copy pasting is the hacker's nightmare. Can I just, no, I can't. You know, he's going to hack this. Right. So now we go back to Chrome, and we have Firefox, the red browser. This means it's the hacker browser. All hackers use Firefox, don't they? It's a way to start a flame war, but yes. So let's assume that this red browser here is your little hacker. So he goes to GitHub now. He clicks sign in. And of course, it's not signed in. And of course, I have the username and password, so I could try to sign in as Elliot, but I have this little extra extension here with that just views the cookies. I'll just delete them all. I just got them now when I visit GitHub. And I do import. And I just paste this string in here and do import. And I have a couple of different cookies. So now, when I click reload on this page, I'm logged in as Elliot. Now I'm running this on the same machine, so it's a bit like cheating. But of course, that's to make it easy for doing a demonstration. But of course, the Firefox browser doesn't have to be in the same machine. It could be anywhere in the world. And I can go in here, because I was looking for the repositories, so I open them up, and I can see they have some really cool stuff here that I'm really interested in. So this is gold now, and I can do anything Elliot can do in GitHub. So go back to my little presentation. So here are the two screens again, the two login screens. It's a bit black at GitHub, I realize that. They look the same. One of them is fake and one of them is real, but they look really much the same, because they are actually the same. Because through my reverse proxy, I just tunnel everything over, and it's the same thing, and so the user don't see anything. If we were to view the source code, there would be slight variations, but it will look pretty much the same there as well. The only difference, and the only little hint that this is not the same site, is the domain name. So on the real side, we have github.com with a little padlock saying everything is okay. And on the fake side, we have github.accountrecovery.io with a padlock saying everything is okay. So from a user perspective, it's very, very difficult to say that this is not the correct one. Accountrecovery.io is a domain that I control, but the user doesn't know that. That could be okay from a GitHub perspective. You know, he's there to do an account recovery anyway, so why not? But we can use this fact as developers. We can use this fact to help our users. I don't know how many of you are front-end developers in here, but I'm pretty sure everyone can follow because it's quite easy. So here's some JavaScript code, very, very simple, just to prove a point. So what this function does is that we'll look at the host name of the location of the window. So basically where this page lives. And it will use a regex that just checks if it's github.com at the end. If it's not, it's going to return false. And then if it returns false, we can actually prevent the login from happening at that point because something is wrong. And everyone was going to thinking, you know, I was told we should never trust the client. It's the worst thing ever. And that is true, But unfortunately, when it comes to these kind of bypass attacks, the client is the best option we have. But we also tunnel this through a proxy that can change any code, any line, any text in that. So if the hacker realizes this is there and it prevents them from doing bypass, they can fix this code on the fly and it will just pass anyway. So we do obfuscation on it. This is a little obfuscation, but you can still see it says github.com at the bottom there. It says something with a window and host, and there's a match and so on. So it's still easy or easier to figure out what's going on. But you can increase the obfuscation, so it becomes much, much more difficult. But you just need to be aware that that makes your site slow the more obfuscation you have. And then again, someone's saying, well, I heard obfuscation is not security. And it's partly true, because obfuscation is a tool in the security toolbox. So by itself, it may not be, full security. But what we're trying to do here is to add time to reverse engineering. Because if a hacker is trying to hack our service, they're going to try to figure out how it works. And if that is difficult, then hopefully they'll just tire and move on to another target, and we have prevented them from actually trying to do bypass attacks on our site. But there are other things you can do. There's something called token binding. So when our user here logs into GitHub and do that through our man in the middle, we also grab a fingerprint from the browser. And you may know what that is. I mean, it's basically just a long string that has information about that browser, makes it fairly unique. There's going to be information about what kind of languages are installed, what kind of extensions, and so on and so on. So when now GitHub or any other service answers back with an authenticated session, which comes to the man in the middle, it's actually being locked by this fingerprint. So this unaware hacker now is going to grab that session token. He's going to move it over to his browser, which of course is red. And then he's going to try to do a login towards this service, and there's going to be an error there. And we're going to invalidate that session. So you cannot try this twice. So you only get one shot. Which is also another way to add more time and complexity to do these hacks. It's just to make it difficult to do too many tries, because he's going to have to trick the user one more time in order to get another session to use. So this is what we have to play with. There are many more advanced ways to do this, and adding randomness to the code will also work, because a proxy usually just do static replays of a string. There's another player in town, though, for authentication. I thought this image was cool, so I just had to have it. It's called passkey. And it's both a hardware and a software solution. So the hardware on the keychain there is a little gadget, a USB stick you put in your computer, and you can use that to authenticate. You may have heard of passkey, so I'm not going to bore you with all the details. And it's also available on any smartphone. Google and Apple has their own solutions. They work with the same standard, which is actually web authentication and FIDO2. Web authentication comes from W3C, and FIDO2 comes from FIDO Alliance. And when they combine those two standards, they get passkey. It's a fantastic way to authenticate because it's passwordless. Most people think, yay, we're not going to use passwords anymore. That's great, because mine was crap because it was my pet's name. Speaking from my own experience. The problem here now is that when we start to run quick with this kind of solution, we have to understand one thing. When we move to passwordless authentication, we have stopped or removed one essential ingredient, which is something you know. Or more specifically, something only you know. It's because now we're just authenticating the device, not the user themselves. Hopefully it's the user that's holding this device and doing this, but we can't be sure. My kids play on my phone, so they could probably authenticate as me if they really wanted to. So this is the danger. It's a very fantastic, secure, cryptographically nice little solution, but we are missing the point a little bit with it. It's reverse proxy resistant, though. So if we did this GitHub attack that I just did, it wouldn't work. And partly it's actually of the same reason that we were trying to do some detection mechanisms using JavaScript. Because what passkey does is that the browser grabs the domain, sends this over to the device, saying, can you do some authentication with this device or this domain? And the device will go, I'll just look and see what kind of keys I have. I'll search through its list and can't find that domain because it's a fake domain. So the whole authentication process stops there, and that stops the attack. Is this bypass resistant? Because there's many attacks. Well, it isn't actually. Don't have the time to do that today. Maybe that's a topic for another talk. But if we were mixing in info stealers here, so the malware that gets installed on your computers to steal things, we can bypass even this kind of multi-factor authentication. So a bit more complicated attack. It requires a lot more things. And nowadays we protect our computers, our endpoints a lot better using things like called endpoint detection response mechanism and so on. So it becomes more and more difficult. But it can be done. So finally, I just want to give you a couple of advice how you're going to protect your applications and services from this kind of attacks. Well, you could use passkey. And of course, that's a recommendation because it is really good. Or you can have it as an option at the very least for your users, if you can. But you should try to avoid using SMS and email as your multi-factor authentication method. A lot of applications use it because it's really simple to implement, it's quite cheap to have, but it's also the weakest one of them all. And this is a very interesting one, and you can easily do this depending on what kind of application you're working on or system. We have to think where we put multi-factor authentication. Normally, you just put it at the authentication when people log in, and that's it. And that's where we stole the cookie now from GitHub. If we also moved multi-factor to a sensitive operation, where you download all the sensitive stuff or add new users or add permissions to someone, so you have to do another multi-factor authentication at that point, then you actually stop this attack not being able to do everything. They can log in, but they can't do the next one because the hacker could only steal the session token at that point at the authentication. Now they have to face another multi-factor and they don't have that. And that's going to be difficult to get the user to accept the second one. It can happen, but it's more difficult. We have to monitor MFA usage. If we see in our logs that there is any number of requests being sent to a person and their multi-factor authentication is an app or whatever it is, we can be pretty sure it's an MFA fatigue attack going on. So then we can detect that at that point. Of course, we developed some detection mechanisms like the JavaScript I showed you, and there's many more advanced techniques that could be done, but there are no 100% foolproof ones. And then we need to remember that the moment we detect something, we need to reset the password of that user and invalidate that session. So if we have in our logs that someone is doing some MFA fatigue attacks towards a particular user, we reset that user's password. So that means that they can no longer actually grab that session token because it's a different state, that user account. It's going to be annoying for that user, but thinking that we just saved that person from having their account hijacked, they should be thanking us. So we need to remember that. We need to minimize the session, how long it lives. And it should never, ever be forever, so just remember that. It's difficult to say how long because it depends on the system. So you have to figure out for your system, okay, this is the minimum time you set it to that. And we should always use the user. The user is our ally in this. If we inform them that something is going on or we suspect that something is going on, they're going to help us because they're going to be aware, okay, something is going on with my account, so I'm going to do something. And the best thing a hacker can do is move into another system. That's what we call lateral movement. So there may be other accounts that's been compromised. And if the user knows that one account is compromised, maybe they can be aware of the other one. So we need to use the user as our ally in this. Finally, I'm just going to say a couple of things because so you didn't actually just misunderstand me in this. So wherever you can use MFA, you should. always. And if you're not using it today, you're going to use it. And that was all you there, 66% of you or something. Start using it. It is the best tool we have to protect our accounts, but it's, by itself, it's not foolproof though. But you have to remember another thing. When you start to use MFA, and I've seen a lot of users doing this, so you get lazy with your password. All of a sudden, it is okay to use your pet's name because you have MFA that covers your back. But that's the problem. In order to do a multi-factor fatigue attack, you need a username and a password. That's all. Then you can send a notification. And then you can send 100 with just those two things. So if your username and password leaks somewhere, and it's easy, it's a weak one, it gets cracked, and then they can use that. So it's very important to still have good password, even if we have MFA. And then finally, something your grandma would say if she was born and raised in the digital age. Do not talk to strange domains. What I mean is that if you go and type in github.com, you know you're at github.com. If you get a button, a link, or something sent to you and you click on that, you didn't type it in, then you have to check what kind of domain you ended up in. Just double check it. It's worth your time and it's good for security. And that's really the end and everything I had. I hope you had as much fun as I did. If you didn't, I still had fun, so that's great. And I hope you enjoyed the rest of this conference, and just thank you so much for showing up.